In this video, we will state and prove the product rule for derivatives. So we know a lot of nice things work with derivatives. So for example, we know the constant multiple rule, that the derivative with respect to x of any constant times a function is equal to pulling the constant outside of the derivative. So that's like a nice property. We also know that the derivative with respect to x of f of x plus g of x is the same thing as taking those derivatives separately, f prime of x plus g prime of x, and that the same thing is true for subtraction. So our question is like multiplication nice in the same way? In other words, is it true that the derivative with respect to x of f of x times g of x is always equal to the derivative of f of x times the derivative of g of x? So is that always true? In order to think about that, I'd like you to try a really basic example. Let's think about the function x squared. So we could write it differently. We could also write that as x times x. And so if the product rule is true, then it should be true that the derivative with respect to x of x squared is the same as the derivative with respect to x of x times the derivative with respect to x of x. So if the product rule is true, then that equation would be correct. So what I'd like you to do is just pause for a moment and check yourself, because we know how to find the derivative of all those things. Check to see if that works. Okay, so the derivative with respect to x of x squared we know is 2x, so that's what this is equal to, whereas the derivative with respect to x of x times the derivative with respect to x of x would be derivative of x is just 1, times derivative of x is just 1, so that is 1. So are those two quantities equal? No, we know that in general 2x is not equal to 1, so the answer to this question is no. And in general, it is not true that the derivative of f of x times g of x is just the separate derivatives. So in general, it is false. In general, the derivative with respect to x of f of x times g of x is not equal to the derivative of f of x times the derivative of g of x. So we need something else to find this derivative, the derivative of a product, and that is called the product rule for derivatives. So here is the product rule. It says that the derivative with respect to x of f of x times g of x is equal to the first, f of x, times the derivative of the second, g prime of x, plus the second, g of x, times the derivative of the first, f prime of x. And just to illustrate it working, we would never use the product rule, or it doesn't really make sense to use the product rule to find the derivative of x squared, but we can if we want to. So we could write that as the derivative with respect to x of x times x, as we saw above. So if the first is x, then that's x times derivative of the second, derivative of x is 1, plus the second, that's x, times the derivative of the first, that's 1, and so that would give us x plus x, that's 2x, and that's also what we'd get using the power rule, 2x to the 1. So great. We see the product rule works in that particular case. Let's use the product rule for something we'd be more likely to take the derivative of. So derivative with respect to x of x squared times sine of x, for example. So this is a derivative that we cannot take without the product rule. We can't just take those derivatives separately. We need the product rule. And so the product rule says that this is equal to the first function times the derivative of the second function. Derivative of sine of x is cosine of x, plus the second function, sine of x, times the derivative of the first function, that's 2x. And we could rewrite that if we want as x squared cosine of x plus 2x sine x. So that is the derivative of that function. We need the product rule to be able to take that derivative. Okay, now let's prove the product rule. So proof of the product rule. And again, that's that the derivative with respect to x of f of x times g of x is equal to the first, f of x, times the derivative of the second, g of x, plus the second, that's g of x, times the derivative of the first, f prime of x. So that is the product rule. Now we are going to do a proof of it. So let's start, as usual, with a definition of the derivative. The derivative with respect to x of f of x times g of x is the limit as h goes to 0 of f of x plus h times g of x plus h minus f of x times g of x, all divided by h. So that's just the definition of the derivative. It's the limit as h goes to 0 of the function at x plus h minus the function at x, all divided by h. All right, so now we are going to do kind of a standard math trick of adding and subtracting the same thing. So this is equal to the limit as h goes to 0 of f of x plus h times g of x plus h. That's what we had before. Now we're going to, in the middle, insert something that's equivalent to 0, minus f of x plus h times g of x, plus f of x plus h times g of x. And note that that thing right there that we just added and subtracted, we added and subtracted the same thing. So that's equivalent to adding or subtracting 0, which is perfectly legal to do, minus what we had before, f of x times g of x, all divided by h. So we still have a quantity that's equal. Now that's equal to the limit as h goes to 0, and we're going to do some factoring. So f of x plus h, we're going to factor that out, and that is in this term, and it's also in this term. So the first thing that it's multiplied by is g of x plus h, minus the second thing it's multiplied by is g of x. And then we are also going to factor out a g of x from each of the second terms. So plus g of x, or each of the last two terms, g of x times f of x plus h minus f of x. So there was an f of x plus h times a g of x and a negative f of x times a g of x. So now we've got everything in the numerator. This is still divided by h. We're now going to break this up into the sum of two limits, which we know we can do by properties of limits. A limit of a plus b is the same as the limit of a plus the limit of b. So this is the limit as h goes to 0 of f of x plus h times g of x plus h minus g of x, all divided by h, plus limit as h goes to 0 of g of x times f of x plus h minus f of x, all over h. And now it might, so we were sort of doing some magic here, there, but now the reason might start to becoming clearer. Notice that what we have here, limit as h goes to 0 of this, is basically the derivative of g, and limit as h goes to 0 of this is just the derivative of f. So to continue that, we want to get the rest of that out of there. We want to separate this limit again as the product of limits. So this is equal to limit as h goes to 0 of f of x plus h times limit as h goes to 0 of g of x plus h minus g of x, all divided by h, plus Now g of x is constant with respect to h. It does not have an h in it, so we can just pull it out front. We don't need a limit for it at all, times the limit as h goes to 0 of f of x plus h minus f of x all over h. And then we can take limit as h goes to 0 of f of x plus h. So as h goes to 0, that just becomes f of x times the limit as h goes to 0 of g of x plus h minus g of x all over h. That is the definition of the derivative of g, plus g of x times the limit as h goes to 0 of f of x plus h minus f of x. That is the definition of the derivative of f of x. And so we have proved the product rule for derivatives. We have proved that the derivative with respect to x of f of x times g of x is equal to the first function times the derivative of the second, the first function times the derivative of the second, plus the second function times the derivative of the first.